Lesson 12.6 is finding reciprocal trig functions. We've already done this with the regular trig functions. Now it's just going back to the reciprocals. It says angle theta is in standard position and -5/6 is a point on the terminal side of theta. What is the exact value of cotangent of theta in simplest form with a rational denominator? So you're going to take this point and you're going to drag it to where -5/6 would be, which is right here. That's going to create this terminal side. So this is the angle really in standard position. But remember, we want to drop down a leg here to make a right triangle, and we're going to use this as our reference triangle. We've got to find cotangent of theta. And then from this angle, let's see. So we went back 5. So I'm going to say this leg's -5. This height is 6. Cotangent actually does not need the hypotenuse, so I won't have to do Pythagorean theorem on this. Think of tangent. TOA is opposite over adjacent. So now cotangent is going to be adjacent over opposite. So that'll be -5 over 6. And that's it. Number 2 does not have a graph. You can choose to graph it or not. What I want to start talking about is what all of the x and the y and the r mean. Given cosecant of angle A, we have 13 over square root of 153, and that angle A is in quadrant 1. Find the exact value of secant of A in simplest radical form using a rational denominator. So cosecant is the reciprocal of sine. Sine of an angle is usually opposite over hypotenuse. I also want you to think about the opposite to every angle. Opposite is always your height of the triangle or your y value. And then the hypotenuse is really the radius of the circle. So that might help you. So then cosecant, if I reverse this, this is really my radius or my hypotenuse. And this is really my y value or my opposite. And they want secant of angle A. Secant is the reciprocal of cosine. Cosine is usually adjacent over hypotenuse, so I'm going to have hypotenuse or r over the adjacent is always your x value. So see, anywhere I draw this reference angle, the x value is my adjacent leg. So if I look at what I'm given and what I need, I have the r, the hypotenuse, and I have the opposite, I just don't have the adjacent. So I would have to do Pythagorean theorem, and so I would have to take the square root of 153 squared plus x squared equals my hypotenuse squared. And so remember, square root and square cancel, that's 153. 13 squared is 169. That's 16. Square root of 16 would make that 4. So that's what x is. So I would have my secant of angle A equaling 13 over 4. So if that totally confused you with the x and y and r stuff, don't worry about it. Just put where that angle's at. It's in quadrant 1. And then you could label, so cosecant would be your hypotenuse over your opposite. And just do it that way like we've been doing, and we found that the adjacent leg, the x value, happened to be 4, and we put hypotenuse over adjacent. That's all we did.